Groovy. So, law of cosine. Let's attack, kill, destroy. Example numero cuatro. 2 ships leave port at 9 a.m. Doesn't this sound like the quintessential algebra problem? The 2 trains leave going in opposite. At 9 a.m. One travels at a bearing 53 degrees west at 12 miles per hour, and the other travels at a bearing of south 67 degrees west at 16 miles per hour. How far apart are the ships at noon? So how many hours passed?
3.
Okay, so noon means it's a 3-hour journey, or it's been 3 hours. So we also have to consider directions. So north 53 west, what does that mean? North 53 west. So here we are. Here's north.
Never eat soggy waffles.
So it's got to be 53 degrees off the north, like this. So it's in the westerly direction off the north. So that means this here has to be 53 degrees. Next, the other one is off the south, also west, at 67 degrees. So here's the south, and 67 off that is here, like this. Now, notice one boat is right here, and the other boat is right here. So what we see clearly is that we can find this angle right here. And how long is this red right there? And how long is the black? So logically speaking, if this guy here travels at 12 miles an hour for 3 hours, that means he is now at 36 miles. And the same logic goes for the black line. Here is 16 miles an hour for 3 hours. So that has got to be 48 miles there. So the question says, how far apart are the ships? In other words, we need to know this side right there. D for distance, C for ABC, whatever. So how big is this angle right there?
67 plus 53 minus 180.
Good, so this is a straight line, 180. Subtract those two from 180. Good, so we do get 60 degrees right there. So if we follow the pattern, this is a side, an angle, and a side. So we have to use the law of cosine here. The law of cosine. I'm trying to find out what C is here. So let me put that in. C squared is equal to 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine of 60 degrees. So plugging all that into a calculator and square rooting, 43.3-ish miles. Very good. So they are separated by 43, which of course makes sense because although this is not an equilateral triangle, it's pretty close. So I did expect my answer to be somewhere close to the 48 and the 36, which that fits well. Heron's formula, this is provable. We're not going to have you prove it, but let's take a gander here. First off, S is kind of like the average, not quite, because we're not dividing by 3, we're dividing by 2. So add up the sides, divide by 2. Put S there, S there, S there, and S there. Next, it's a product of all these with S minus A, S minus B, S minus C. And in the end, we square root. So the derivation of it has to do with sine and cosine, but all we do is just calculate S, plug a bunch of stuff in, and we're golden. So, for example here, find the area of a triangle whose sides are 31, 52, and 28. So the first thing to do is to find this mystery letter S. So we just take 31 plus 52 plus 28, all divided by 2.
That's a nice number.
And so we get 55.5. Okay, now what do we do with that? We're going to subtract that from every side, or subtract every side from that, while multiplying things out. So my area is going to be 55.5 times 55.5 minus 31, which is that one there, 31, times 55.5 minus 52 times 55.5 minus 28. Don't forget, it's a product, 4 numbers, and all radicalized. And 361 point, and we can just go to the nearest tenth, and 0.8. In this case, there is no unit, so it's unit squared. Notice it's hard for us to tell what the approximate value is because it has to do with area, and area is always a square unit. So, I mean, if you had to draw this problem, notice the 31, the 28 are close together as the same size, and 51 is clearly longer, or 52. So it might look something like this, where I have a 31, a 28, and a 52. And the best you could probably estimate would be like, oh, let me multiply these two right here to see what I get. But in the end, it's actually hard to estimate, so we just check our answer there.